Binary search algorithm searches for an element in an ordered list using a process in which at every step of the algorithm the list remaining to be searched gets divided by half. That is, if the element for which we are searching is not found. For this example, we'll be searching in a 13-member list with index ranging from 0 to 12. So we'll be searching for the element 201, or rather number 201, which we'll be searching using binary search. So let's define our lows and highs pointers. So in this case, we have the whole list, and the low pointer is at 0 and high pointer is at 12. And remember, this is a sorted list. One of the primary criteria of using binary search on a list is that the list should be in sorted order. So now to find the mid element, we do 0 plus 12, the indexes of low and high added together by 2, which gives us mid as 6. The element at 6 position, or the mid position, is 101. Now we need to determine whether the mid element is less than, equal to, or greater than the number we are searching. So first we compare with equals. In case we have already found the number, then we can stop searching at this point. So we compare 101 to 201, and we find that 201 is greater than 101. So this brings us to an important conclusion, that since 201 is greater than 101, which is the midpoint, and the list being in sorted order, so all the numbers before and including the midpoint will all be smaller than 101 or equal to 101. Since our number which we are searching, 201, is greater than 101, so it will not be for sure found in the locations prior to or equal to mid. So keeping that in mind, we can effectively ignore the list till the midpoint. Now, ignoring the list till the midpoint in our case is simply moving the low pointer to the position mid plus 1, that is, to the point from where we can have the number 201, and the high pointer remains where it is. So now our low index becomes 7 and our high index becomes 12. Now we again find mid value, which will be 7 plus 12 by 2, or 19 by 2, which is 9. Ninth index contains the number 179. We again follow the same comparison process, and we see that 179 is not the number we are searching for, and so we see if the number we are searching for is greater than 179, and it is indeed greater than 179. So what we do is we again follow the same process, and we discard off, or rather ignore, all the elements less than or equal to 179 at index 9, and so we move the low index to mid plus 1 position, which is 10. So our low now moves to 10 and our high is at 12. So we now have low at 10, high at 12. We find its average, which is the mid position, and mid comes out to be at 11. Now we again compare the number at mid position, that is 356, with 201, and we find out that 201 is less than 356 this time. So that means all the elements at index 11 and higher are of no use to us because they are all greater than 201. So now what we do is we move the high pointer this time to mid minus 1 position, which is nothing but 10th position. So our high is at 10th position, our low is at 10th position itself, and our mid also is at the 10th position. So now We compare the element at mid with 201 and it is indeed the element we are searching for. And so this is how we find 201 using binary search. Let us now see how to implement the binary search algorithm we just saw in action in an iterative and then in a recursive manner. So let's start looking at the Java code and let's quickly go through it to understand both the implementations. Let us first look at the iterative version and see how binary search algorithm works in an iterative manner. So first we define our class named iterative binary search and we pass to it a list of integer type of objects and an integer number which we will be searching for. We also pass the initial low and high values for the algorithm to use in the first instance or in the first iteration. At this point, let us understand what an iteration is. An iteration in our case will be where we have a low and a high defined, and using a mid we find out whether we have found our number or we need to again move the low or the high pointer dependent on whether we have the number to be found less than mid or greater than mid. And the loop continues till low remains less than or equal to high. So we first find out the midpoint and then we see whether the element at the midpoint is equal to the number to be searched. If yes, then we print that the number has been found and the index. Else we see whether the number to be found is less than the element at mid position, in which case we know that we have to eliminate the list to the right of mid including mid, so high becomes mid minus 1, or the last case remains, the last else, that is, as per which the number to be found is greater than mid, and so low is moved to mid plus 1 as we saw in the animation as well. And if low becomes greater than high without the number being found, then the loop is exited and false is returned. The determination of the number being in the list or not, or binary search algorithm to end with a true or a false, depends on either the number being found at a mid position or low exceeds high without the number being found. Let us now move to see the same implementation done in a recursive way. The recursive algorithm is almost the same as the iterative version. The only difference being that instead of a while loop, the method calls itself. In the case of recursive algorithm, low greater than high becomes the boundary condition for ending recursion. So once low becomes greater than high, the method returns a false and the algorithm itself returns a false. This is similar to while loop ending. However, if low is not greater than high and the algorithm is continuing, then recursive algorithm works by doing the same mid determination, finding out whether mid is less than the number to be found, equal to the number to be found, else greater than the number to be found. So those three conditions are still checked. The difference is that in case of the number to be searched being less than the number at the mid position, the same method is called again and the value of high this time is passed as mid minus 1, while the value of low remains the same and the list and the number to be searched are passed back as well. And similarly, in case where number to be searched is greater than the number at the mid position, the lower half of the numbered list is ignored by setting the low to mid plus 1 position. In this way, the recursive algorithm proceeds via multi-level recursive calls until low becomes greater than high, in which case it returns false. Otherwise, it keeps on recursing till low remains less than high, and wherever the element at midpoints equals the number to be found, at that point it prints the index at which the number has been found, or which is the index of the mid position, and exits with the success. So this is how binary search works in a list using the iterative and the recursive versions. If you like the explanation of the binary search algorithms working and the code walkthrough, then please do like this video. Also, please subscribe to the channel Java Brahman, where I am planning to cover all the important algorithms which we learn in a computer science course, in a typical computer science course, with algorithm explanation as well as their Java implementation. Thank you.